the smallest kind you're supposed to eat already, have a larger dose. Then diagnostic X-ray machines typically produce high exposure rates during brief time interval. What we call our X-ray machine. We don't spend hours a day. Just go in there, take your shot, and then come out. Even that small exposure, that little time, you already have a high dose of radiation. You are already exposed to a high rate of radiation. And that's why experts will tell you that you cannot repeat some X-ray procedures at close interval. You need to give some time. I will ask you when last did you take one, so that at least they save your life. So reducing the time exposure to radiation, reducing the dose received, and the percentage of reduction is directly proportional to time. So one principle of is to reduce the time because of that sort of. Then the second one is the distance. The greater the distance between the person and the source of radiation, the smaller the amount of radiation, dose of radiation reduced. When we talk about distance, it follows the principle of inverse dual law. The amount of dose received decreases inversely with the smaller of the distance from the radiation source. But summarily, what we need to know at this level is that if it is practicable, let the distance between you and the radiation source be increased if it is practicable. Then shielding is where you now use a protective material, either the one you wear on yourself or the one that is placed in the laboratory area you are carrying out the experiment. So shielding is used in diagnostic, biology, and nuclear medicine to reduce exposures of patients, staff, and the public. The staff working on the patients receiving the treatment, and then if there is any leakage of waste, you need also to detect the public. So when we do shielding, you have yourself in mind as the expert, the patient, and then the public. The decision to utilize shielding and type, thickness, and location for a particular application are functions of the photon energy in the intensity and the geometry of the radiation source. So you don't just pick anything and say I should shield myself. No. There are things that determine the type of shielding, the thickness, and where that shielding materials will be placed. The term biological shield refers to the mass of absorbing materials placed around the reactor or other radiating source to reduce the radiation to level safe for humans. So that's the purpose of the shield. It's not that the shield will totally eliminate the radiation, but it will reduce the level that is safe for us. Necessary facilities, walls surrounding the room with the X-ray generator with the contained electricity. That's an example of shielding. In the room, no one knows, you just enter. But the walls are already shielded so that the exposure of the patient and the staff to radiation is minimal. Or a plaster may contain radium sulfate, which is also a shielding material. So operators can view the target through a lead glass screen. There's a glass screen that the person that is viewing it is being shielded from the radiation source directly. Or if they must remain in the same room as the target, they wear lead apron. At times when the operator of the machine may not be away from you or viewing you from a shielded glass, he has to be able to wear the apron and made of lead. So shielding may be installed in a wall, floor, or ceiling of a room. So you can enter a room like this. You already have some shielding materials to reduce exposure to radiation source. This is commonly done for rooms containing X-ray imaging machines, CT machines, and sometimes rooms housing patients administer large activities. Also, it may be, number one, in the walls of a cabinet used to store radiative sources. If a cabinet is used to store radiative sources, shielding can be in the wall of the cabinet, so that each time you go to the cabinet, you are protected from radiation. It can be installed around the work area, such as the dose reclamation area in the nuclear medicine radiopharmacy. So you can have shielding around the work area. It is incorporated behind the image receptors of fluoroscopes and radiographic machines and the gantries of CT devices. Or it can be worn as a protective apron by people performing fluoroscopy. It can be as a movable barrier, such as the freestanding and ceiling-mounted shields in fluoroscopy procedure rooms. So protective shields are used to reduce and absorb radiation, and lead is the most important material used to block radiation. So you should know three alarm principles. You reduce the time, you increase the distance, or you use the shielding material. When you use the shielding materials, it can be worn directly or it can be placed in the room, in the store, around where you are. The principle is just that you want to reduce the radiation exposure as much as possible. So some examples of shielding materials. Shielding store radiation before it reaches the body. The mosquito lead is the most important that we use because it is dense and absorbs radiation effectively and it can last for a long time. So we can have lead aprons that can be worn by staff, sometimes patients, and when you do that, it can reduce radiation exposure by up to 95%. We have lead gloves, we have lead glass screens, we have lead iron walls. But shielding is not just about lead, so now use lightweight alternative like tungsten or barium plastic composites. Because those ones are thinner and flexible, and they are just as effective as the lead material. So another compliance and regulatory framework. Hospitals must follow the radiation protection series and guidelines, which set exposure limits and best practices. So compliance is not optional, it's compulsory. Hospitals need to calibrate their machines regularly. The importance of that is to ensure that the radiation doses remain within safe limits. You think that the dose limited is this. If you need to calibrate the machine, you start prescribing more than what you plan for. You need to train staff continuously, updating techniques and reinforcing safety measures. When we are talking about time, reducing time under another principle, I told you that you need to train your staff so that they will be able to work at a faster rate. So training staff continuously is part of the regulatory thing that hospitals need to abide with. Then monitor exposure levels by using dosimeters to track radiations absorbed by workers. So that if you discover that somebody is already being exposed to something that is going to kill him, there's a way we can rescue that person, either with MKA or then we have radiation monitoring and personal protective equipment, which we call the PPE. Hospital track radiation exposure using dosimeters. These are small badges that measure cumulative dose. Workers wear them on their chests, fingers, or even inside lead aprons to check for leakages. So PPE plays a key role in malaria. In high exposure area, staff can wear the neck aprons. That's the standard protection for X-rays. Thyroid shields, those ones cover the neck where radiation sensitive tissue is located, and the lead glasses protecting the eyes from scattered radiation. So the new materials are making PPE lighter. Traditional lead aprons weigh 5 to 7 kilograms. But newer design use lead alternative composite that are 30% lighter with sacrificing protection. So there are other materials that are lighter and as effective as a lead and can use as protection. So what are the challenges and future directions? Another works, but it is not perfect. So some challenges persist. We can have emergency situations. In emergency situations, speed will take priority. Over time to say the person is having exposure, you can quickly do something to rescue the person. Rural hospitals, they have limited resources and make compliance to malaria harder. So that's another challenge. Patient movements, maybe you have somebody to go and carry out X-ray, and then you brought it, they said the image is stolen. And then they need to go and limit that. We should take into consideration that the patient is being exposed to radiation. And of course, if your imaging is not perfect enough, there is no way you can be there because the professional need to see what it can treat you for. So technology in my head, AI-powered imaging systems are emerging, automatically adjusting radiation levels based on patient anatomy. This will cause doses by 30 to 50% without losing image quality. There is a way you can individualize a particular patient. The AI-powered imaging system that studies the anatomy of the patient and can automatically adjust the radiation level given to that particular patient. So with this technology, about 30 to 50% reduction in radiation doses can be achieved. In the meantime, radiologists, technologists, and mosquito associators continue refining techniques, and the goal remains the same: the maximum diagnostic benefits with minimum radiation risk. That's the goal of the treatment. We want to get the best with minimum risk. Generally, in treatments, what we consider is the risk-benefit relation. If the benefit you are going to get outweighs the risk, you will still go ahead, ignoring the risk, since you know that you have the benefit. So the goal is that you have the maximum diagnostic benefit and the minimum radiation risk. Radiation protection and safety. The primary means for controlling potential exposure is by optimizing the design of installations, equipment, and operating procedures. We do this to restrict the probability of occurrence of events that will lead to unplanned exposures. You know, we already know that you will be exposed at some level, but there will be some unplanned exposure. So we design and install our equipment to guard against that, so that there won't be any emergency exposure apart from the one that is preempted. Then to restrict the magnitude of the exposures that will result if such events were to occur. Even if you cannot guard against this emergency exposure. So you will have planned that even when they happen, it's going to be in the barest minimum, so that the person exposed can be rescued. The radiation exposure covered by the basic safety standards document encompass the exposures, both normal and potential, of number one, workers pursuing their occupations. There are standards for workers working in radiology departments to reduce exposure to radiation. The patients either go to diagnose them or they are in treatment. So those are also medical exposures. And then the members of the public, if you are dealing with traditional material anywhere, you must ensure that there are no leakages that is going to be detrimental to the public. Because we are going to know that traditional materials are coming from the perspective. We need to take it into consideration. So radiation exposures are therefore divided briefly because of time to stop. They are divided into three. And what we call occupational exposure is defined as all exposures of workers in the course of their work. You are doing your work at other pharmacies, house, technologies, and then know that also materials are going to be exposed. But this is the exception of exposures excluded from the PSS and exposures from practices or sources exempted by the PSS. So we cannot classify operational exposure, we cannot classify an exposure as occupational exposure if it is not invading the one already allowed in the PSS. Then the medical exposure defined as exposure by patients as part of their own medical diagnosis or treatment. By patients that have gone to the hospital and they know going for you to be well treated, you need to be exposed to there's no way they can help you if they are going to be well treated. They need to expose that because they know the benefits you are going to get at the end of the day. To get you correct diagnosis or get you correct treatment, we outweighs the risk you are being exposed to. So such exposure is classified under medical attention exposure. By those occupationally exposed, knowingly why following health in support and comfort of the patient. Why the patient is being treated or diagnosed. There are some people that are also around. Because we need the assistance to support that particular patient. So if that person, even though it's not the one being diagnosed or treated, if it's exposed to radiation, it's still classified under medical exposure. And that person has to hear. Because if you want to assist somebody, you should be ready to take the risk associated with it. Then by volunteers in the program of medical research involving their exposure. So if you volunteer to participate in the research, and then by participating in that research, you need to be exposed to some radiation. So exposure is still classified under medical exposure. Public exposure is defined as exposure incurred by members of the public from radiation sources, excluding any occupational or medical exposure. And the normal program natural background radiation, but including exposure from authorized sources and practices and from intervention situations. So when somebody is having a public exposure, we won't classify occupational exposure or medical exposure as public exposure. If you are exposed because of your job, if you are exposed because you are a patient, or because you are assisting the patient, or because you are a volunteer in research, you are not going to classify your exposure as public exposure because all those places you are already aware that you are going to be exposed to radiation. It's just that we want to see to make it as low as possible. So because of our time, let me just stop there. this section, we want to take just three, what's our time? Just three. One, two, three. So that people are going to take any start from number 3. I'm going to have a microphone. Thank you very much, sir. My name is Ogoji. The question is to ask Speaker, sir. Please, bro. The purpose of the lecture is the head is the most important material. You use structure of the radiation due to this density. And that's the ability to absorb effectively and at the same time can last for decades. Being is a case of toxicity. Lead is not extremely toxic. So it is a toxic material. Why are we using it? Thank you. Thank you so much. My name is Smooth. I have two questions. My first question is to you, and second is to previous. My question is this: looking at the analogy around bacteria facilities for hypertension, you suggest that hypertension is curable rather than going towards anti-manageable. Is there a possibility of shocking aldosterone? To attract aldosterone, we know which of these are very effective. I'm sure. My question is this: we look at exposure occupational public exposure and losing efficiency for getting treatment. I seem to figure out that the people we term beauty seems to architecture like people's exposure. They're also trying to ask us how we for people and the process of I'm trying to get the occupational exposure. What is the special course? You see that the patient was once get exposed and this exposure. Probably get exposed in case of breakage or leakage. But this person is his job. It's not considered the patient. It's not public presence. What's another thing to from Monty University of Chicago. My name is student of biology. I'm directing my question to Professor Frankie. What is question about hypertension and hypertension? I'm trying to relate the aldosterone because it helps the kidney to retain more sodium in your blood, thereby creating a high volume of blood and leads to high blood pressure. But also another reason as allergies and the how do you relate to it as a protein that converts the glycogen to one. Then AC that converts 1 to 2 that causes consumption of the body leads to high blood pressure. Sometimes I work in computational biology and chemistry, majorly. Which one will be a better drug target for me as a computational chemist? The secondly, I will also use specs as an imager to monitor the pathway or ready just like aldosterone. Thank you, sir. Thank you. Yeah. Thank you. First of all, somebody asked concerning the toxicity of lead. If lead is toxic, why are you using it? Well, toxicity of lead has to get into you before it becomes a toxic. But this time around, we only use it as a protective shield. We are not going to inject the lead. It's not going to be absorbed into your body. We're just using it as a protective device. So there's no way to exposed to radiation flows. Every work has its own risk. There's nobody that we do without being aware of the risk. In fact, if you are doing any job, you are not conscious of the risk attached to it. Please go and sit down and study the risk and think twice. With this risk of my job, do I still want to go ahead or I want to leave it? Although there are standards, there's no way they will not be exposed. There's no way they are not at risk. But at least let it be the nearest minimum. There are standards. So if the exposure the person is getting is already outside the standard,
it's not showing anything.
the person can sue
Okay.
the place of fault. But if you see within part of the risk of the profession. I don't know whether they are medical days or competitive in one area or other. And maybe they are working in the hospital and educate us. But there's no some technologies in our school. Just get one camera in and then I started eating his flesh, and then these are those standards. So, if you are making a job, you are aware of this risk. A lot of us in chemistry, there's some chemicals for. Let's go under a few come.
I need to know and I want to be sure that the network is fine. I will mute myself and I will mute
and we are aware, not that we are not aware. But what I can just advise them is make sure that take all the necessary precautions so that the exposure you get to is within the acceptable limits. It's not that their life is not being affected. At least it won't be cut short suddenly. Thank you.
Oh, don't worry. I know what the problem is. Zoom, hoje imagina.
producing things, actually automate things, building attention, and that's the bottom of the topic. So I guess for better. I'm monitoring for the survey, but I think it's all. So I'll be back to the question I'll ask about the answers to it. I'm not sure if you're seeing exactly the sense that this is a kind of common treatment for hypertension, or is that just to know in this case, the ADA is a kind of just one form of hypertension. It's just one form. Wider cause of hypertension or all kinds of causes. Really, there's no specific case. The best cause is having a good lifestyle, there's alcohol, that's the kind of common thing of treatment. Why is this specific cause? And the cause is your treatment plan use so in a way, you have a kind of a target way of saying this would cause this, and I'm going to treat it. And of course, now they can actually use this kind of imaging technology, find the specific cause, in this case, this is one of treatment plan, and such for previously, and really changed it. It's a bit like Alzheimer's, that things are
Sir, you are not sharing the slideshow. Abby, what I'm seeing there is.
Someone, if they identify the government land, the surgery takes out because you can manage the land. Previously, the surgery land for state that now, we've actually reduced the communication issue that is happening in the movement, is that it's not about knowing that it's not monetary plan, it's still knowing that it's taking out the monetary plan. Maybe I can develop this kind of targeted treatment where you can use ablation and target kind of ultrasounds, sonic things, to go in endoscopy, go to the treatment plan, and still taking the whole treatment plan, you target the area that's causing the high aldosterone, and it's really accentuating its ovulation. It's targeted, it's hidden, and treated. That is just an absolute game changer. It's not happening for the surgeon, DEA, or the anesthesia, go in and do that. Then do the CQ, do the bedside, you identify the cause, one plan, you go in there, you do the endoscopy, and you have the radiation, and you use target actual treatments. And that was one form of that. Then the stage of two, they can do treatment, but when you do then do treatment for the whole population. So it's very time and technology that's because it was actually sitting the area, but they will do around that's holding the aldosterone, and then use that treatment to use. So that's the difference in it's really over my calculation. There's a large cause, but they say it's significant. I think for about the area with the road, so when you get it, it's a good form in Nigeria. The other cause, I can say, yes, we have actually treated it. You can't argue what you got. So I'm going to about the other question. You maybe just like to clarify it is. Who was that?
My question is, healing is very substantial in Eadioligan. For example, in reducing severity, it is including that the last analysis is one. And this is not what analysis is. And it is almost a fast constriction. I'm trying to compare Eadioligan. I'm trying to compare Eadioligan, which is used harmful.
If this vaccine is including stimulants, so developing the traces, these days, so the latter image meaning of something. But the opportunity for something necessarily, but that only of something, maybe I project and I for attention, but that is hard for going forward. And then you will attention something that that's the kind of concept of but also the achievement as well. So if you look at this first generation, it is relevant and by far that we can use to target and give us that information. How far from what goes through, how goes through, the BD to BD one line inside that exists.
Thank you very much.